Daddy, there's germs on the outside of them. I gotta go. My class has already started, okay? I will. I will. Okay. All right. Bye-bye. You too. Okay, we got people coming in here. See. We got Haley, I got Katie, Anai, Tori, Jennifer's waiting to come in. How are you guys doing? It's the last full week. Are you counting the days? Probably. I am. I'll admit it. Okay. Let's see. I got Jennifer in, Katie and I, Bree, Tori, Haley. Okay. All right. Guys, I want to talk about what I'm gonna be doing for the rest of this week, and then how we're gonna sort of finish up here, and then we'll proceed to do that. Let me get while I'm waiting, let me share the screen here. It's not that one. Okay. Let's see what I got. Okay. All right. Let me show you what I've done for the next assignment sheet, and then it'll be the last one. What's on it is all we're going to do. You know, I'll work on it this week, and then the material that there'll be another test, but that test is going to be very short, and it's why I'm trying to give you these short quizzes, and I'll try to post all those online, the keys to all those online as soon as I start getting them in. The material is not particularly hard, but it's a little bit, it's a new technique. It's not hard, but you need to do the homework or you're not going to know what you're being asked, and that's part of the problem. So let me show you what everything looks like here, and we'll talk about what we've got to do today. So let me see if I can find the new assignment sheet here, guys. When I look at, these are where I've got all my lectures stored, and when I look at them, I realize just how much work we've all done. A lot of work. I never kind of looked at it in one place like that before. I just kind of went day to day, and it's a lot. It's been a lot. And it's been under challenging circumstances, so we're going to try to finish it up as best we can. This is what the assignment sheet looks like. I'm gonna go over what we did on Thursday. There were only a few people on Thursday, but there was something really important that I did on Thursday, so I'm gonna go over a little of that again. And then I'm gonna talk about how we apply this thing called the antiderivative. And that's what the rest of the week's gonna be out. How do you use this thing? And then there's something else called the definite integral versus the indefinite integral. We'll talk about that. The quiz on derivatives of exponential functions is on Moodle. I have said I will accept it on this thing until tomorrow at class time, okay? And that's the one that I had due today. Some people have emailed me about it, and some people sent it to me. We'll talk about that, and we'll go over it again. Again, I've gotten to the number of quizzes where any additional quiz you do, if the grade's higher, it'll replace a lower one. So, I mean, if you didn't do any of these quizzes, you'd have the grades you have now in homework. But that doesn't solve the problem of knowing how to do the material. And that's why I'm giving these short quizzes, so everybody can just have a chance to look at the kinds of problems that are going to be on the last really, really short test. There is a quiz due tomorrow. I don't know. It's a quiz on antiderivatives. It's also on Moodle, and that's what I'm going to start off with today, to talk about what I did Thursday and talk about how we apply those things. The next thing we're going to do is area. We'll do that on Tuesday. I've sort of broken down the homework into different pieces. There'll probably be one more quiz here, and it won't be due until Thursday. I'm not going to have and we'll do some work day. Thursday, I'm leaving it, to tie up loose ends so that I try not to do any new material there. I'm not going to do any new material next week. That's a 3-day week. It's that short week before reading day. I'm not doing anything new. What I get done this week will be what I get done. We'll have a couple of review days for the test to make sure everybody, and I may even give you a sample test to work on, okay, that we can go over on Monday. Tuesday, the test will be posted on Monday. It'll be due on Wednesday before class. Wednesday is our last day. I hope I've got that right. I think there were 3 days during the week of reading day. Now, the final exam. We will have this 4th test. We'll have your quiz grades. I will have your average for you as soon as I get that 4th test graded, which should be, you got to get it into me by Tuesday because I'll get it back to you on Wednesday. I would give everybody their average. If they are happy with their average or whatever grade, or you get a pass or whatever you opted for, you will not have to take a comprehensive final. Okay? I think that's the best thing to do here. However, if you have a low test grade that you would like to see a better grade in the place of, you can take the comprehensive final, and if you make higher on the final than that low grade, I'll put the final exam grade into that slot. I'll dump the lowest grade and I'll put the final exam grade into that slot. I will, if it's not good, if it's lower than your lowest test grade, it won't count against you. It will not count against you. Okay. So, so there's a way, and you're, in some ways the final should be a little easier. I've still got that second test that I could never get back to you. I'm trying to find it in all these millions of files I've created so that I can at least mark it and send it back to you, but I will have a key to every test before the end on the Moodle site. So that's the way it's gonna play out. I don't know how many, only your advisors were privy to the knowledge about whether you took pass, no credit, or a grade. I don't know what any of you took really, unless I've talked to you personally about it. And we can sort of have that discussion when I give you your average and when you're trying to decide what to do in terms of the final. But I don't know how many finals you're having in other classes. I kind of feel like people might be loosening up in a way. I mean, I never taught this course before without giving a final, period. I just never did. And I had reasons for that, but I got good reason not to give one now that's required. I'll give it to you as a way to better yourself on the grade. But I'm not going to give it to you as a way to figure out what this semester's been like. Okay. So questions, anybody about that? Anybody got a problem or a question that I can answer?
When you say short test
Yeah.
or test 4, what is that going to be graded, like weighed the same, even though it's shorter?
Yeah, I think I will, because I think it's on less material and I think you can do well on it. I will give you a sample test and we'll talk about it. Okay.
Okay.
And the sample test will look similar to the test. Okay. So, so that might help. I'll do that I'll give you that by Thursday. You can work on it and then we can go over it together on Monday, and then I'll post the test late Monday and you can do it again. So it'll be, you can do a similar test. I just think that's the way to go. It's not on much material. It'd be on the exponential stuff that we did, the compound interest stuff, which was just basically formulas to use and a few graphs. And then this idea of the antiderivative.
Okay, perfect. Thanks.
Anybody else? Okay, let me find what I wanted to do today. Let's see if I can find it. We talked about on Friday, we talked about what was called an antiderivative. And an antiderivative is actually when you're given a function and you're asked to find whose derivative it was. And if if you think about it, when we were finding derivatives, if we we had a power rule. And if we found the derivative of x cubed like this, we said, okay, what's the derivative of x cubed? You brought the 3 down, you took away 1, and you got 3x squared. So you multiplied and you subtracted. An antiderivative is going in reverse order. What you're going to do with an antiderivative for a power rule is you're going to add 1 to the power and divide by that power. It's just literally undoing the function. Okay, you're finding out where did that derivative come from. That's what an antiderivative is. So let me just, with that, and you can watch the lecture on this, but let me do a couple of just new examples here. Okay, so suppose I had this one. Suppose I had find the antiderivative of 6x to the 4th dx. It's an antiderivative. You can do similar things with an antiderivative. That's what this symbol means. It's called an indefinite integral. And I'll talk to you again about why that's called that. It's called an indefinite integral, and it is nothing more than an antiderivative. So I can just write the 6 down, just like the derivative of a constant times the function was the constant times the derivative. And now what I'm going to do is use the power rule for antiderivatives on that. And it says add 1 to the power and put it over that. So what I end up with is 6x to the 5th over 5. Now, there's something else I want to put with that, but I'll tell you about that in a minute. So that's the function whose derivative should be 6x to the 4th. You can always check it. If I said take the derivative of this thing, pull the 5 down, it'll cancel, take away 1, you'll get 6x to the 4th. You can always know if you got the right antiderivative, because if you differentiate it, you'll get right back to where you started. Now, there's one thing that you need to remember on these things called indefinite integrals. You could also add any constant onto that, because the derivative of any constant would be 0. So you would still get 6x to the 4th. You would still get 6x to the 4th. Okay? So, so I'll give you a couple of other examples. Let's see if I can get a spare page here. Okay. Let's do that. I don't know where it went, but we'll try. Okay, here's another page. So suppose you're going to have to do the same thing with these things that you did with derivatives. You're going to have to rewrite them so you can use this power rule on it. And here again, here's the power rule for antiderivatives. You can bring any constant in or out, and if you have a power, you will add 1 to that power and put it over that power, and then you put a plus c. Okay.
So if we forget to put the plus c, what happens?
You'll get docked for it. And I don't mean to be vengeful, but when I was in college, it kept hitting me. My professor kept hitting me for it. I mean, it won't be much, but I'm going to show you why it's important in a minute. Okay. The plus c is easy. If you find one of these, what we call indefinite integrals, just write at the top of the page, don't forget plus c, and put on all of these, put plus c's. But the point is, we're going to try to find the c eventually. Okay. So suppose I had this, the integral of 4 over x cubed. Now, if I wanted to differentiate that, I would have to have rewritten it. I'm going to have to rewrite it here too. What can I do to get that power up there? Because this power is up in a numerator, okay? What would I have to do to get the power up there?
4x to the negative 3rd.
Okay, I'd have to rewrite it as 4x to the negative 3. Okay, now I'll use the rule on it. The 4 is just a constant. I will add 1 to the power and put it over that same thing. I just automatically put the plus c on there, so that's going to be 4 over minus 3 plus 1 is minus 2. So I'll get x to the minus 2 over minus 2 If I want to simplify that, it would be minus 2x to the minus 2. All I did was divide that minus 2 into 4. And then if I want to drop the negative power, not the negative 2, just the negative power of x, that's what I would get right there. So it's a simple rule. It's a simple, what we call power rule for antiderivatives. I'll give you another one. And the key again is rewriting things. So for example, if I had f of x is the cube root of x, and I want to take the integral of that, or the antiderivative. I want to know whose derivative is the cube root of x. I am first going to rewrite it. How do you rewrite the cube root of, actually let's make it the cube root of x squared, guys, so we'll know what we're doing here. How do you rewrite the cube root of x squared?
X to the 2/3.
Okay, I'm hearing Haley. Is everybody okay with that? X to the 2/3. Remember, we look at that. Now, it gets a little ugly here, but it's still the same rule. It's an easy rule. Take the 2/3, add 1 to it, and put it over that same power. Not the x, but the 2, sorry, no x there. The 2/3 plus 1. Now, you leave it in a fraction. You do not use your calculator here. There's no need to do that. So what you get is x to the, now 2/3 plus 1, 1 is 3/3. So 2/3 plus 3/3 is 5/3. That's going to be 5/3. When you invert and multiply, you'll get 3/5 x to the 5/3. Once again, if you can check it. You can multiply 5/3 times 3/5. You can take the derivative and you better get right back to here. 5/3 times 3/5 is 1. Take away 1, which is 3/3, and you'll get x to the 2/3. And that's exactly where I started. You can always check it and always know it's right. Now, one other caution here. Let's see if I can get me another page here. Let's see if I can get. Okay. To give a couple more examples. You suppose we had the integral, the indefinite integral of x squared times 2x minus 1 dx. Now, if I've got a string of additions, I can do every one individually. I mean, you can differentiate things that are added and subtracted without using any fancy rules. But if you had a product, it was a lot harder to find the derivative. So the ones we're going to deal with are going to be simple. If they're products, you need to multiply out first. Okay, so if they're products or quotients, we need to multiply out or divide. So I would do this one as 2x cubed minus x squared dx. Okay, now I can do these individually now because they're just separated by minuses. So again, if I use the power rule, there's a 2. I'll take x to the 3rd and add 1 and put it over 3 plus 1. If I have x squared, it'll be x to the 2 plus 1 over 2 plus 1, and that's plus c. And then I'll have, if I simplify it, I'll have 2x to the 4th over 4. You can reduce that fraction if you want. Minus x cubed over 3 plus c. And if I were to ask you to differentiate that, you'd get right back to this, which we know is that. The derivative of any constant is 0. So that's the basic idea of the constant is when you take an antiderivative, say, of 2x, and you'll get 2x squared over 2 by just adding 1 to that, plus c, what you'll get is x squared plus c. There are lots of functions that look like that. So if I were checking that, I might say, well, what's the derivative of x squared plus 5? If that was that, what would y prime be? Well, it would be 2x. So the derivative of 5 is 0. I could have the function y equal x squared minus 1. The derivative of that is 2x. The point is you need that c there because you could have a lot of different functions that had that same derivative because the derivative of a constant is 0. All right. Another sort of tip here, if you had the integral of 2 dx, you don't see really a power there. But if I ask you guys, whose derivative is 2, you'd say, oh, well, it's just 2x. So one thing you might want to remember is no matter what I do here, if I say, if there's just a constant there, the integral of 5 is 5x. The integral of 1/2 dx is 1/2 x plus c. So you can think about that in this way, guys, if you want to. If I had 7x, if I just had 7, erase that, you could really think about it as x to the 0 power. Because that's just 1, and it just gives me 7. But when you add 1 to 0, you'll get 7x to the first over the first, and that's what you get. You get 7x. Okay? So this power rule is pretty easy. All right? You just have to add a power, add 1 to the power, and put it over there. Questions, anybody? That's what the quiz that's due tomorrow is on. It's on Moodle. Look at it. The problems are not particularly hard. You just either have to rewrite them and use the power rule. At the top of it, write, don't forget plus C, okay? I'm not going to count off much, but I am going to count off something because it really is important. All right, so here's why it's important. Suppose I said, like I said a minute ago, what's the antiderivative of 2x? The antiderivative of 2x is x squared plus c. Now, what we know, and again, you can check. The derivative of x squared plus c is 2x, and the derivative of c is 0. So you get right back to 2x. So you're really saying, whose derivative is that? Well, it's the derivative of this function right here. Now, we know, suppose I said x squared, suppose I said c was 0. Then the curve we'd be looking at would be that curve, okay? So we might have that curve right there if c was 0. If c was 2, that might shift it up 2, and it might look like that. No, the y-intercept will be 2. Suppose c was equal to x squared plus 3. Same basic shape, except that it ran through 3. So that one went through 0. That one went through 2. I'd sort of left 1 out, but there's 3 right there. Now, what we say is that these are all members of the same family. So if you forget the plus c, you're ignoring the fact that there are lots of members of the family. Okay? So, and that's what you need. You need, generically, let me get it out of the way here. You need to put that plus c on there. Get all this out of the way. Okay, so here's what we're going to do. If I want to identify a particular member of the family, then I'll say, well, this member of the family right here, even though it looks like, certainly looks like a parabola, it is a little different because it goes through different points. It's like that's your father right there, and you're just like your father, but you got a little bit different about you. You're going up a little ways here. Even if I let x squared be -1, what it would do would give me a curve down here that went through -1, but they all look the same. But if you give me a particular characteristic of the brother right here, that member of the family right there that's in blue, if you tell me he goes through the point 310. So in other words, if you plug 3 in, you should get 10, and you'll have that member of the family. Now, this y equal x squared here doesn't go through 310. It goes through, remember it was the curve y equal x squared, okay? And clearly, if you plug 3 into that, you get 9. So this one went through 3.9. The other member of the family goes through 3.10. So they do have something different about them, but they're basically the same. It's just that if you tell me that one characteristic, that one point that they go through, that that particular curve goes through, I can tell you what curve it is. I can find you that C. So here's what I'm going to do. Let's suppose we had the following problem. Now, if I give you a curve, say here we had y equal x squared plus c, and I said the member of the family that I'm interested in is the one that goes through 10. So that's the point 310, guys. So what happens here is that you're going to plug in the point 310 and find out what C has to be. Which one is the one that goes through 310? Well, if I plug in 3 for x, that'll be 3 squared plus C equal 10. If I take away 9, I get C equal 1, and that member of the family looks like this. He's the one that's got a 1 on the end of him. Okay? And you can check it. His derivative is 2x, just like all the members of the family have the same derivative, but they go through different points. If I put 3 into this one, 3 squared plus 1 is 10. Okay? This thing right here is called a particular solution. I have picked out a particular member of the family because that particular member is the only one that passes through the point 310. None of the other ones pass through that point. Okay, so I want to do another problem. The question before I go on, I'm going to do the same thing on a different problem. All right, so this kind of problem is called a differential equation. And here's the one I'm going to do right now. Right there. I'm going to block it away from that one, guys. I want to know what these family members look like. And I know all their derivatives look like this. All the derivatives look like that. And for this particular family member, I know that family member passes through the 0.24. So the first thing I'm going to do, if I've got f prime and I want to find f, I will anti-differentiate. So that'll be f. I'm going to anti-differentiate this thing so I can find the generic family. That's pretty easy to do. I'm going to use the power rule. And that says f of x. If I find the antiderivative of 3x squared, it'll be 3, add 1, and put it over that. So I added 1 right here to the 2. I put the 2 plus 1 down in the denominator. Okay? 3x cubed over 3 is x cubed. Now stop and check yourself real quickly. What's the derivative of x cubed? It's 3x squared. So you're given the fact that these are all these family members have this derivative. What does the family look like? What's the integral of 1, guys? And there, the minus will go there. Now, we talked about this just a second ago. What's the integral of 1? Whose derivative is 1? Well, go ahead.
Would it be 1x plus c?
Yeah, it would be 1x, and I would put a c with it, okay? And I'm going to put the c on it in a second. But keep in mind, guys, if it's just a constant, integral of 5 dx is 5x. Integral of 15 dx is just 15x. And I do need the plus c. 15x plus c. Okay, so I'm gonna get rid of that. But because now, what's the derivative of 1 again? Tell me again what the derivative of 1 is. The antiderivative, what's the integral of 1? It's just 1x. Now, I don't need but 1c on here. There's 1x, and then I'll add the c. Okay, I'm going to get rid of that conversation down below for a second here. I'm going to get rid of this one. Let me get rid of it that way. Get rid of it like this. So, what have I found? What I found is that every member of the family looks like this. But this defining, they're different from the members of their family because this c might be different. Even though they all have the same derivative, that c might be different. Now, I want you to see how I'm going to find the c. I know that for this particular member of the family, if I plug 2 into the function, I should get 4. They're giving you a point, guys. They're saying, oh, I'm different from every other member of the family because I'm the only one that goes through 2, 4. And you can find his C from that. I don't know why I keep saying his, her C, okay? So that's what happens here. It says if I plug in 2, which will be 2 cubed minus 1 times 2 plus C, I will get 4. That tells me that 2, 4 belongs to this member of the family. Then all I have to do, so the f of 2 is the y, and the x is 2. Okay? That'll be 8 minus 2 plus c is 4. That says 6 plus c is 4. That says c is minus 2. That says c is minus 2. So here's, long story short, here is the member of the family that I was looking for. X cubed minus x. I found the generic antiderivative for the whole family. Then I said, I plugged in the point to find out what c had to be for that. C had to be minus 2. So there's the member of the family that has the same derivative as everybody else in the family, but that one goes through this point right here, this 2, 4.
So first you go backwards and find the antiderivative. Then
Yes.
you plug in the.
You plug in that point you're given.
So you plug in the x
Yep.
coordinate.
Yeah, x, you plug in x for 2 and the value of the function. Remember, y is f of x. So you just plug in that 2, and when you plug it in, you should get 4. That's the x, and that's the y, or the f of x, or however you want to think about it. Okay? So this is called a particular solution. I have picked out a particular member of the family here. I'll do another one. Once you do this a couple of times, you'll figure out what's going on. So let me see. I'm going to see if I can get up another page and do another one. Okay, I'm going to add a page after that. Suppose I had this one. Suppose I had f of x. Suppose I said this, and here's what it's going to look like. Solve the differential equation. It's called a differential equation because it's got a derivative in it, and you want to find out where that derivative came from. Where we have this, where f of x, where f prime of x is equal to, let's see, the square root of x plus 2x, and contains the point let's just say 2, 7. So I don't know exactly what that thing looks like. I mean, the derivative of something is that. So if I want to find out the actual function, I'm going to take the antiderivative. So the antiderivative of the square root of x plus 2x dx, first thing I'm going to do is rewrite. So that's x to the 1/2. I don't have to rewrite that one. And now I'm going to use my power rule. If I add 1 to the top, to this power right here, I'll add 1 and put it over that. And then I'm going to look at this power, which is 1. I'm going to write 2x squared over 2 for that. And the way I got that was to put plus 1 plus 1, and then put it over that same 2. And then there's my generic family. I'm going to simplify it in a second. Does everybody see I just used the power rule on that? 1/2 plus 1 over a half plus 1. The 2 is already there. If I add 1 to this, I get x. I get 1 plus 1, x squared over 2, and I get that. I'm going to simplify it, guys. 1/2 plus 1 is 3/2. When I divide by 3/2, I'll invert and multiply and get 2/3. The 2's will cancel out in this one. And I'll get the function, the function that's the description of the whole family. All that's different about this family is that this C will shift them up or down, because that's what happens when you add something onto a function. You add some C onto it, it just takes whatever the curve is, shifts it up or down. Now, here's the way I'm going to find which member of the family that is. Here's the point. The point was 2, 7. That means if I plug in x equal 2, I will need to get y equal 7. Okay? So I'm going to do that. So it's going to be 2/3. Oh, 3. You know what, guys? Because this is going to come out ugly, I'm going to change what my member of my family looks like. I'm going to say it goes through 4, 7, and you'll see why I'm doing that in a second. I'm just doing this to make it look nice. I'm going to say the member of my family goes through 4, 7 instead of 2, 7. Just thinking about what I wanted to happen instead of what I was doing. Okay, so it's not. Let's just pretend we started out there. Okay, so that means I'm going to plug in 4 here. That'll be 4 to the 3/2 plus 4 squared. I plugged in the x there. I plugged in the x there. Plus c, and I better get what? I plugged in the x. I better get 7. Yep, that's what's going to define this member of the family. Now, guys, real quickly, 4 to the 3/2. Put it in your calculator if you want to, but that's just the square root of 4 cubed. And 4 cubed is 64. That's just 8. So what I wind up with is 2/3 times 8 plus 16 plus c equals 7. That's 16/3. I forgot my c. Yeah. That was a plus. Plus c equals 7. So that's 16/3 plus 16 plus c equals 7. Now I just got to figure it out. I just got to isolate c. So c equal 7 minus 16 minus 16/3. Wait a minute, can't get my pen to write. Minus 16/3. And guys, all I did was isolate c. I moved over the 16/3, that's why it's negative. I moved over the 16. So c is minus 9 minus 16/3. Put it in your calculator if you want to, but that's minus 27/3 minus 16/3, and that's minus 43/3. It's not pretty, but that's what that. So that member of the family's got something a little bit odd, not a nice fractional part. The answer to the problem is this. Now, go back to what you were trying to find your C here. Your C, you have found out that your C here, let's do this, is whatever I said it was, minus 40, what did I say it was? Minus 43/3. So that thing right there is minus 43/3. And that's the answer to the problem. That's what the function is equal to. That's the function that has the same derivative you wanted, and it also goes through this odd point, this 4, 7. You're just finding the C. Now, where could that ever be useful? Let's spend the last few minutes talking about where this gets used. The problem work tonight is some of these things to do, and then some of the applications. Suppose we had something like this. Let's look at that problem right there. Okay. Sometimes we know the rate at which something's changing. And remember, the rate is a derivative. But maybe we don't want to know its derivative. Maybe we want to know what it is. So here's a great example. If I say, suppose the marginal cost of producing an item is C prime equal 32 minus 0.04 x. If it costs $50 to produce 1 unit, find the cost function. Now, guys, remember from what we talked about earlier in the course, marginal is a derivative. So now we got the derivative, but we don't have the cost function. Before, we were given the cost function and asked to find the derivative. Now we're given this rate of change of the cost, and we want to know what the original cost function was. Okay? So here's what they're doing. They're saying, okay, here's the derivative. I want to know C. So I'm gonna integrate this. C will be equal to the integral of 32 minus 0.04x dx. Now this integral sign and that dx always go together. They're just a package. It's finding the antiderivative with respect to x. Now I'm going to use the power rule on this. The power rule for antiderivatives. What's the integral of 32, guys? What's the integral of 32?
32x plus c.
Yeah. And you know, Haley, I got you going with the plus c. We're going to do all of it and then put the plus c on the end, okay? But you're right. You got to put the plus c on it eventually. But right now, I'm going to say 32x minus. Now, the antiderivative of this one is going to be 0.04. Whoops. Is going to be 0.04 x squared over 2. Notice what I did. That was a power 1. I just added 1 to it, and I got 2, and then I put it over 2, and I'm going to, in the end, add my plus c. You only need to add 1 plus c, so we may as well just do it at the end, but don't forget it. Now, here's the question. There's a cost function, and that c is like a little c. There's a constant there. That's a cost function that could be a lot of different cost functions depending on what c is. Here's how you find c. Have they given you any more information in this problem right here? Anybody? Have they given you any more information?
So they gave you 1 unit. So would you plug that in to find the?
Yeah, they're telling you it costs $50 to produce 1 unit. So that says if this is the point X and C, this thing's for 1 unit, it costs $50. They're giving you a point to plug in so you can find C. So here's what I get. I'm gonna go ahead and plug that point in. That means if I put in 50 for C, that should equal 32 times 1. Notice I'm putting the 1 in for X and the 50 in for C. And I'll get minus 2 into 0.04 is 0.02. Put the 1 in again, plus C. Okay, and I should be able to solve for C. Let me do that. Unfortunately, I'm not going to do this problem right here, so I'm just going to go down below it. I'm going to finish it up right here. Forget about that. I'm not worried about that. It pops up in the homework. I'll talk about it later. So that says 50 is 32 minus 0.02 plus C. I need to solve for C. 32 minus 0.02 is 31.98. If I subtract 0.98, I've got 50 minus 31.98. I'll wind up with C equal, somebody get your calculator here, guys. What's 50 minus 31.98? Anybody?
18.02.
Okay, thank you. 18.02. So the cost function that I have here is this. The cost for this particular item, whatever it is, go back up here to what we said. It was 32x. And again, that was from right before you found the C. Right there. 32x minus 0.02, whoops, 30, shucks, get out of here, 32x minus 0.02 x squared plus 1802. Okay, now let me say a quick word about what's going on here. There's the cost function that if you take the derivative, the marginal cost would be 32. Derivative of 32x would be 32. Bring this 2 down here, it would be 0.04x to the first, and the derivative of the constant would be 0. So you can check it. That's where you started. Now, why is this cost function different from other cost functions? Well, all the cost functions that have this part have the same derivative. But this constant right here is different for this cost function. Suppose I ask you this. What did I mean by fixed cost in a cost function, guys? What did I mean by fixed cost? You remember what a fixed cost was?
That's like something that doesn't change. So like
Yeah.
your
Yeah, it's something that doesn't change. It doesn't matter how many items I produce here. Even if I produce 0, I don't know, maybe this functions in millions, but even if I produce 0, the fixed costs are 18.02. It takes me that much money to get started. And then maybe it's this constant hanging out over the end that are the fixed costs for this particular function. Now, there's one other thing you could ask. And if I send it through, if I gave you a different point, you come up with a different fixed cost. So that constant is important, and I got it by taking the antiderivative, plugging in the point that I gave you, and finding out what that C had to be. Now, suppose I said, now, okay, for this whole thing, suppose part B was find the cost, and this is C of X right here, and X is the number of things you produce. Find the cost for producing 100 items. Find the cost for producing 100 items.
So you would just plug in 100 to that equation?
Exactly. And I couldn't have done that, guys. All I had before was a marginal cost. I had the derivative. I didn't have the cost function. So now I've found the cost function I'm interested in. So the cost of producing 100 items is going to be 32 times 100 minus 0.02 times 100 squared plus 18.02, and I don't know, maybe it's in millions, whatever. So I need my calculator. Let me get it, and then you guys can work with me while I'm fiddling around here. 32 times 100, and then I'm going to subtract 0.02 times 100 squared. And then I'm going to subtract 1802, 0.02.
You would add that, right?
Oh, shucks, you're right. Hang on, messed up. I did. I should have added it. I'm going to go back in there, and I'm going to put a plus in that spot instead of the wrong thing I put there. So I'll put a plus, and then I'll shuffle back through, and I'll find out what that's equal to. It's like I don't have the right, I'm going to delete that little thing that I put in there and enter it. 30,1802. Can I get verification on that since I had such a hard time finding it? 3018.02 units, dollars, millions of dollars, whatever. So guys, if you're given a derivative and you want to go backwards, you're going to use this antiderivative to do it. Now, here's my suggestion for the homework tonight. That quiz, there's a quiz on antiderivatives, remember. I would do that first, make sure I understood how to use this power rule and how to rewrite things. And then, so that's due sometime, get it to me sometime today and I'll get it back to you. It shouldn't take too long. And then I can't remember was there another one due that I put in here today? Yeah, there was another one with the applications on it, or maybe not. Let me look. Sorry. Where's that sheet? Here's that assignment sheet. Blah 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 blah.
I think it was just the quiz on the exponential functions and then the quiz on
Oh,
the
you're right. It was I was giving you extra time on the quizzes on the exponential functions, and then I want the antiderivatives. And then the next thing I'm going to ask you to do is do some of these that I just did today. That will not be, do your homework on that tonight, but that's not a quiz. So the derivatives on exponential functions, which don't look anything like this stuff, and then do that antiderivative sheet using this power rule. That's right. You're absolutely right. That's what it was. Since I can't find it right now. Oh, what a lot of stuff. 5, 6, there it is. There it is. Yeah. So tonight, you need to work on, if you did not get that derivative quiz for antiderivatives, I talked about that on Thursday and Friday. Okay. So if you want to go back and look at the video, the tail end of Thursday and the beginning of Friday, because on the beginning of Friday, I did a review of that. And then on Friday, I did the power rule, and I did it again today at the beginning of the day. So both of these will be due tomorrow by the end of the day. Okay, guys, I'm backing up with assignments here, so get it to me as fast as you can, and I'll get it right back to you. So just like, if you got this vision of me sitting in front of my computer waiting for things to come to grade, it's about right. Okay, so I take time off to fix myself lunch sometimes, except yesterday when I didn't think about eating until it was supper time. I'm like, my God, what happened to the day? But anyway, I'll talk to you tomorrow, and we'll continue some of this tomorrow. I will give you sort of a sample test on this as you review, so you sort of know what you're expected to know.
Okay, I have a question on the exponential derivatives quiz.
Mm-hmm.
So on part 2, where it says, like there's A and B.
Okay. So what's your question? Say,
well, for A,
what's it say?
It says find the slope of the tangent line to the curve f of x equals 5e to the negative 3 at the point x equals 1. So
5e to the negative what?
F of x equals 5e to the negative 3x.
Yes. Okay.
So I'm looking at the example problem that we did in the notes, but I'm stuck.
Okay, everybody listen. Slope of a tangent line to the curve is a derivative. Okay? So if you want to find the slope at any point, you got to find the derivative of that. And that's what I'm asking you to look at tonight. You got to find the derivative of that. I'll give you a hint. The derivative of any function that looks like e to the g of x repeats the function e to the g of x and then multiplies by the derivative of g. So if you get that and you plug in a point, so what did it tell you a point you wanted?
It says at the point x equals 1.
Okay, so I'm going to find the derivative of this, and I'm going to plug in 1, and I will have the slope. And no, it's not a pretty number. It's a crappy looking number. Okay?
So you plug the 1 into the derivative
Yes,
function.
that's what you do to find slope, isn't it? You look back on your first test, I gave you a nice, easy little polynomial, and if you wanted to find the slope, you plug that into the derivative. That would give you the slope. And then if you wanted, did I ask you to find the equation of the tangent line or just the slope of the tangent line?
The B part says find f of 1 and write the equation of the tangent line.
Okay, so the second part of that is, first thing you got to do is find the slope by plugging 1 into the derivative. Now, you don't know the 1, but if you want an actual point, remember you got to have a point to write a line. Y minus y naught is the slope minus x naught. You need a point. What you want is the x coordinate to be 1. How do you find what goes with a 1? How do you find out the point on the graph? Tell me where you go to find, not the slope, but how do you find the point on the graph?
Would you plug it into the original equation?
Yes. Everybody, that's what you're going to do. You're going to plug it in the original. And it's not pretty. It's ugly. Okay?
I got a fraction.
Say that again?
I got a fraction. I'm not sure if that's correct, though.
It's not, well, it depends on what it's probably more going to be like a decimal value, Katie. So,
okay.
for example, I'll show you what had happened in this one. If you said y equal 3e to the x squared, the slope would be given to you by 3e to the x squared times 2x. Remember, you repeat it. The 3 just gets put there. The derivative of the power is that. if you plug in 1, you're going to get, if you plug in 1 to this, you'll get 3e to the 1 squared. And then I would put that in the calculator. And if I found out what 3e was, all right, so 3 times e to the first, I get a decimal. I get 8.15. And just, that's what you would get. I mean, you can leave it like that, but that's what I get on the calculator, about 8.15. These are not pretty numbers. I'm not sure how you got a fraction because you're plugging it into something with an e in it, Katie.
I sent my quiz to you. Is there any way that you could look at it? Because I am a little bit confused about the last part.
Okay, well, that's what, here's what I want you to do. I want you to take that, I will look at it, okay? I want you to take the derivative, whatever point I gave you, if it was 1, put it into the derivative, and you'll find the slope, and then put in 1 to the function, you'll have a point, and then you can plug it into point slope form.
So to take the derivative, you just repeat the equation, and then you take the derivative of the power.
Right. And if you guys will go look at what I did Thursday and no, last Wednesday and Thursday morning, there's so few people here Thursday morning, that's what worried me a little bit about this. But do that, and you should be able to differentiate this thing.
So once you find the slope and then you plug in 1 to the original function, that gives you the y, so then you can write the equation?
Yep.
Okay.
You got there's the point. You just found the slope by plugging into the derivative. Put that, and you know how you find a point on the graph? You plug it into the original. Katie, I'll look at it and send it back to you, okay?
Okay.
Okay. Anybody else question? All right. I'll see you tomorrow. Okay.
Thank you.
You're welcome. Bye.
Bye.
Bye-bye.